For decades, T-Rex ruled our nightmares as the ultimate prehistoric killer. Movies, museums, and childhood imaginations all bowed before the tyrant king's massive jaws and bone-crushing bite. But paleontologists just confirmed something that changes everything we thought we knew about apex predators. There was something bigger, something deadlier, something that made T-Rex look like an oversized house cat with anger issues. This is Spinosaurus, and the evidence we've uncovered proves it was the most terrifying predator that ever walked the earth. What happened next will completely shatter your understanding of prehistoric dominance. Hollywood sold us a lie that lasted over a century. T-Rex dominated our imagination as the undisputed king of dinosaurs. Massive jaws capable of crushing a car, teeth like railroad spikes, and a bite force that could snap a telephone pole in half. Every museum visitor stood in awe beneath those towering skeletons. Every child's dinosaur book featured that iconic silhouette, and every paleontologist measured prehistoric predators against the T-Rex standard. But here's what those museums don't tell you when you're staring up at that 40-foot skeleton in wonder. T-Rex wasn't even the biggest predator of its time, not by a long shot. 95 million years ago, in what's now the scorching Sahara desert, mighty rivers flowed through lush tropical forests. The landscape looked nothing like today's endless sand dunes. Instead, a network of waterways supported an ecosystem so rich and diverse it would make the Amazon rainforest seem barren by comparison. And lurking in those ancient waters was something that made T-Rex's legendary 12,800-pound bite force look like a gentle love bite. The Moroccan fossil hunters who first discovered the remains had a name for this creature that captured their primitive terror. They called it the river demon. Scientists would eventually classify it as Spinosaurus, the spine lizard, but that clinical name hardly does justice to the monster we've now reconstructed from decades of painstaking research. Dr. Nizar Ibrahim from the University of Portsmouth dedicated 15 years of his career to hunting Spinosaurus fossils across the unforgiving Saharan landscape. His team's discoveries in 2014 and the groundbreaking 2020 study published in Nature magazine didn't just add another dinosaur to the fossil record, they completely rewrote the rules about what prehistoric predators could be. The first clue came from the spine bones themselves. Where T-Rex vertebrae measured a respectable 8 inches in height, Spinosaurus vertebrae stretched nearly 6 feet tall. These weren't just bones supporting a massive back sail for temperature regulation, as paleontologists had initially theorized. These were the architectural foundation for something far more sinister. But size was just the beginning of the revelation. When Ibrahim's team analyzed the bone density using advanced CT scanning technology, they discovered something that defied every assumption about large terrestrial predators. Spinosaurus bones were incredibly dense, almost penguin-like in their structure. This wasn't the lightweight, hollow-boned architecture of a land-based hunter optimized for speed and agility. This was the bone structure of an aquatic apex predator designed for life in the water. The implications were staggering. Every textbook, every documentary, every scientific paper about dinosaur ecology had to be reconsidered. We weren't dealing with a terrestrial predator that occasionally waded into rivers to catch fish. We were looking at something far more dangerous, an aquatic killing machine that could hunt with equal efficiency in water and on land. The reconstructed skeleton tells a story of evolutionary perfection that should terrify anyone who understands predatory biology. Those dense bones weren't just for buoyancy control. They were ballast, allowing a 20-ton predator to dive beneath the surface and ambush prey with the stealth of a crocodile and the killing power of a great white shark. The skull measurements revealed another shocking truth. T-Rex skulls maxed out at about 5 feet in length, already impressive by any standard. Spinosaurus skulls stretched over 6 feet, but their design philosophy was completely different. Where T-Rex developed massive jaw muscles for crushing bone, Spinosaurus evolved for a different kind of lethality entirely. Those elongated jaws weren't designed for the brutal bone-crushing attacks that made T-Rex famous. They were precision instruments of death, lined with over 100 conical teeth that curved backward like fishhooks. These weren't weapons for delivering a single devastating blow. They were designed to grip, hold, and drag struggling prey underwater until it drowned in prehistoric terror. The bite force comparison tells only part of the story. T-Rex could deliver 12,800 pounds of crushing force in a single bite, enough to pulverize the spine of any herbivore unlucky enough to find itself in those jaws. Impressive, until you consider what Spinosaurus brought to the equation. Those conical teeth could penetrate and hold prey weighing several tons. The jaw structure was optimized for gripping power rather than crushing force, but the real weapon was the killing method. Spinosaurus didn't need to deliver an immediately fatal bite. It just needed to grab its victim and drag it into the water, where size, strength, and air-breathing biology all became fatal disadvantages. The Cretaceous rivers of North Africa were packed with potential prey that would challenge any modern ecosystem's carrying capacity. Onchopristis, a sawfish that reached 25 feet in length. Carcharodontosaurus, a land-based predator nearly as large as T-Rex that came to the water's edge to drink. Sarcosuchus, a crocodilian so massive it earned the nickname Supercroc and measured over 40 feet long. Spinosaurus hunted them all, and we have the fossil evidence to prove it. Excavations in Morocco's Kem beds have revealed fossilized fish bones with distinctive puncture wounds. The spacing and depth of these marks match Spinosaurus' teeth perfectly, but the size of the prey fish tells an even more remarkable story. These weren't minnows or small river fish. These were giants of their aquatic ecosystem, some measuring over 6 feet in length themselves. But the most terrifying discovery was yet to come. When paleontologists analyzed the largest Spinosaurus specimens using advanced scaling techniques, the results challenged every assumption about dinosaur size limits. The biggest T-Rex specimens measured approximately 40 feet from nose to tail and weighed an estimated 9 tons. Impressive by any measure, and certainly worthy of the King of Dinosaurs title that popular culture had bestowed. Spinosaurus shattered those records completely. The largest specimens measured 59 feet in length and weighed an estimated 20 tons. This wasn't just a bigger dinosaur. This was a predator operating in a completely different category of lethality. To put that in perspective, Spinosaurus was longer than a modern school bus and heavier than 4 full-grown elephants. The swimming adaptations revealed through recent research add another layer of nightmarish capability to this already formidable predator. That massive paddle-shaped tail wasn't just for steering or balance. It was a propulsion system capable of driving 20 tons of apex predator through water at speeds approaching 25 miles per hour. For comparison, that's faster than most recreational boats and considerably faster than any creature trying to escape by swimming. The foot structure told another part of the story. Where T-Rex had developed massive, weight-bearing feet optimized for terrestrial locomotion, Spinosaurus feet were partially webbed and designed for both swimming efficiency and riverbank traction. This wasn't a predator that occasionally ventured into water. This was an animal equally at home in aquatic and terrestrial environments, giving it hunting opportunities that no other large predator could exploit. So what would have happened if these two apex predators had actually encountered each other in combat? The timeline makes such a meeting impossible. T-Rex dominated the late Cretaceous period in North America, while Spinosaurus ruled the middle Cretaceous waterways of North Africa. But the fossil evidence gives us enough information to conduct a theoretical analysis of their respective capabilities. T-Rex was the ultimate terrestrial killing machine, built for hunting massive herbivores across open landscapes. Those bone-crushing jaws could deliver a fatal bite to virtually any land-dwelling creature, and the powerful leg muscles could sustain pursuit speeds that would run down even the fastest herbivores. In a terrestrial environment, T-Rex represented the pinnacle of predatory evolution. But Spinosaurus operated under completely different rules. Rather than specializing in a single environment, it had evolved to dominate multiple ecological niches simultaneously. Those powerful swimming capabilities meant it could pursue prey that entered water, while the massive size and powerful claws made it formidable on land as well. The hunting strategies were equally different. T-Rex was an ambush predator that relied on explosive power and devastating bite force to secure kills quickly. Spinosaurus was more akin to a modern crocodilian, using patience, stealth, and environmental advantages to overcome prey that might be larger or more powerful in a direct confrontation. Recent analysis of fossilized stomach contents has revealed prey items that demonstrate just how versatile and capable Spinosaurus really was. Shark remains measuring over 20 feet in length, coelacanth fish weighing hundreds of pounds, pterosaur bones from flying reptiles with 30-foot wingspans, even remains of other large dinosaurs that had ventured too close to the water's edge. This wasn't opportunistic scavenging. This was systematic predation across multiple environments and prey categories. Spinosaurus had evolved into something that had never existed before or since. An apex predator capable of dominating land, water, and even aerial prey that flew too close to the surface. The environmental dominance was unprecedented in the fossil record. T-Rex ruled terrestrial ecosystems with unquestioned authority, but its influence was limited to land-based interactions. Spinosaurus controlled rivers, coastal waters, floodplains, and forest edges. No prehistoric predator had ever achieved that kind of ecological influence across such diverse habitats. But perhaps the most significant discovery was how this changes our understanding of dinosaur diversity and specialization. For decades, paleontologists assumed that large theropod dinosaurs were primarily terrestrial hunters with occasional aquatic capabilities. Spinosaurus proves that dinosaur evolution was far more creative and adaptable than anyone had imagined. The engineering challenges of creating a semi-aquatic predator of this size were immense. Maintaining body temperature in water while supporting 20 tons of muscle and bone required metabolic adaptations that we're only beginning to understand. The cardiovascular system had to function efficiently both in water and on land. The respiratory system had to support both surface breathing and potentially brief diving. Every aspect of Spinosaurus anatomy represents a solution to problems that no other dinosaur had to solve. The result was a predator so perfectly adapted to its environment that it dominated North African waterways for over 30 million years. That's longer than T-Rex existed, longer than humans have been walking upright, and longer than most entire dinosaur species managed to survive. So why does T-Rex still capture more popular attention than the demonstrably more impressive Spinosaurus? The answer lies in fossil preservation and geographical accessibility. T-Rex fossils are found in the American West, where extensive paleontological expeditions have been possible for over a century. Museum-quality specimens are relatively common, and the political stability of North America has allowed sustained research programs. Spinosaurus fossils, by contrast, are found primarily in the politically unstable regions of North Africa. The Sahara Desert isn't exactly tourist-friendly, and many of the most important fossil sites are located in areas where sustained scientific expeditions are challenging or impossible. Most tragically, the original Spinosaurus specimens discovered in the early 1900s were destroyed during Allied bombing raids on Munich during World War I, World War II, setting back research by decades. But thanks to paleontologists like Dr. Ibrahim and international teams willing to work under challenging conditions, we're finally uncovering the truth about Earth's most impressive predator. Modern technology, from CT scanners to 3D modeling software, has allowed scientists to reconstruct Spinosaurus with unprecedented accuracy using fragmentary remains that would have been useless to earlier generations of researchers. The implications extend far beyond paleontology. Spinosaurus represents evolutionary innovation at its most extreme. When environmental conditions created opportunities for a semi-aquatic apex predator, evolution responded with a solution so effective it dominated its ecosystem for millions of years. This kind of adaptive creativity suggests that life on Earth has always been far more diverse and innovative than our limited fossil record indicates. T-Rex was undeniably impressive, earning its reputation through sheer terrestrial dominance and bone-crushing power. But Spinosaurus was operating in a completely different league of predatory evolution. The next time someone tells you that T-Rex was the ultimate prehistoric predator, remind them about the 60-foot river demon that made the king of dinosaurs look harmless by comparison. Spinosaurus represents the true apex of prehistoric predatory evolution, a monster so perfectly adapted to its environment that it achieved dominance across multiple ecological niches simultaneously. In the hierarchy of prehistoric terror, nothing else even comes close.